We can also solve the previous problem with a far simpler approach. So if we have this configuration like a three cylindrical solid shafts in row between two fixed support at A and E, and we want to calculate a torsional torque at the second support, we can solve it with far simpler approach. So that's a normalization of torsional stiffness. So we can convert the whole material to one solid shaft and then solve the problem and calculate it for T sub E. Let's see how we can do that. So by torsional stiffness, we means Gj over L. So if you look at the configuration, if we call the first part and calculate the polar moment of inertia for that one, that J is equal to 1 a half of pi C to the force or R to the force. So that says our radius for this part is 5, diameter is 5 inches. So that's a C1 is 2.5, and for the second part, J2 is a half of pi 5 to the fourth, and for the last part, J3 is a half of pi 7.5 to the fourth. And it just says we can jot it down J1, J2, and if you get the relation of J2 over J1, it's just 16 times bigger than J1, and likewise J3 is 81 times J1. So if we consider J1 like J, the second one is 16J and the third one is 81 times J. In doing so, we can convert the top shape to a similar diameter shafts. So if we want to have Gj in the numerator remains the same for all shafts, we have to work out on the denominator. So Gj, 16 Gj, 81 Gj, and the first one is Gj over L1. For the second one, we can have, because this is 16 times bigger in the numerator, so the only way we have, it's L2 over 16. That 16 comes back to numerator. Let me show you here what's happening here. If we have the original length, this is our original L2 75 inches. And if you divide it by 16, this number moves to the numerator and gives us the original 16 GJ. So that simply says, and do the same for the third one. So this is 81 and the original L3 is 75. If you divide it by 81, 81 moves to the numerator and gives you the original 81 GJ. It simply says for the rest two parts, simply divide the original length by this number. So 75 over 16, make it 16 times smaller to get this one, normalized GJ. And for the third one, divided by 81 divided by 81 to get this one. So that says numerator of all of them remains the same. We work on the denominator to get them all the same. That's physically says, graphically says, this shape with different diameters, it just moves to a this shape by so it just says 75 over 16. It just says it just shrink to 4.68 inches, and the third part, which is 75 inches, shrink to 0.93 inches, less than 1 inches. And that makes a huge change in solving the problem far simpler. Let's move back to axial force. Let's consider a two fixed support beam which is handling a axial force of P. You can just convert it like a vertical one, And definitely the support closer to the force has a bigger chunk of energy or bigger share of the force. So you can easily say by statics get the reaction at A, that's 2/3 of L, and the RD is 1/3. So it just says you can apply to the same fact to torsional torque. This is axial force. For torsional torque, if you have a shaft and a torsion apply at 1/3 from the A and 2/3 of length from B, you can easily know that share of TA is bigger. So that's a T times 2/3 of L times T is equal to TA. So the same, we use the same fact like axial force in torsional torque, and we want to apply to our shapes. So if we want to calculate T sub E for our case, so the total length is 60 inches, remains the same, 40 inch remain the same, plus this one plus this one. So the overall length of is 105.61, and TE is 75 times this distance, which is 104.68 over the overall length. So that's the share of this support, that's the share of E from this torsion. Definitely a bigger chunk of that a torsion should goes by support E, and the smaller chunk you can easily see 104 over 105, it's almost 100% of that one, almost 95, 96, whatever. The bigger chunk of distortion is related to support because that's very close to support at E. And likewise, for this one, we can say this length, so that's 40 plus 60 is 100 over the overall length times 880. And for the last one, this length, which is 60 over overall length, so that's 590 pound-feet times 60 over overall length, and that simply gives you TE. And the same numeric value with like previous problem, you can get TE much quicker than first approach. Thank you. We'll solve more problems.